All right, guys, welcome back to Tech Intern. Today, I'm joined with Javin Aimbridge for, I think, the third time total. And Javin and I created this extension called Lead Party, which I have been hyping up for a few weeks on Tech Intern. And today, we are actually going to try it out together. So we're going to basically be competing. We're going to open a leak code, and we're going to see who can solve the problem.
A friendly competition all about self-improvement. Let's make that clear.
Yes, exactly. So it should be fun. I think today our rankings are completely based off how fast we complete the problem. But in the future, it's going to be like dynamically determined off of your memory usage, your runtime, and how long it takes you to write it.
As well as if you view other people's code, that'll be extremely detrimental to your score, and you will definitely not win. So that feature will soon be rolling out to the market across the world.
Nice. We've got a lot of really cool features coming up. So let's just jump in, and I'll kind of show people how to use it as we go. So we've found a problem here. It's called number of good pairs.
You should share the screen.
Oh, that's a good point. I thought I was, but I'm not. Share. So basically, all you have to do is find a LeetCode problem that you want to work on. And you actually don't even need to find a LeetCode problem. If you're not on LeetCode, then this Chrome extension will bring you to a random problem. But right now, we're on a problem. If we want to learn how to use it, we just click the information button, tells us exactly how to use it. That's going to look a little prettier in the future. But it is what it is for now. So I'm just going to go ahead and start a party. It's just me in there. I'm going to grab that link.
And it's a pretty good name, Domestic Cockroach.
Cool. So right now it just gives you a generated name, but we're going to have it so that you can pick your own name in the future.
You got to send me the problem.
Yep, I'm sending it to you now. So there's the link. And you can see right now, since we haven't started the game, that's deactivated. I can't start writing code behind Javin's back. Okay, he's readied up. So I'm going to ready up too. Everybody's readied up. Now the host, who is me, can start the game. I haven't even read the problem, but I assume I'll be able to tackle it. All right, put that down there. All right, you ready?
Yep, let's do this.
Start. Okay. Number of good pairs. Given an array of integers, nums, a pair ij is good if I equals to j and I is less than j. Return the number of good pairs. 4 good pairs. 0 to 3, 0 to 4, 3, 4, 2, 5. Okay. So there's a really obvious brute force solution here where you just go through each place and then you run through the rest of the array to see if that, if it makes a good pair, which of course would be a really easy solution, but it wouldn't get you the win in this feature that's coming up soon, because another person could easily write a better runtime function and beat you.
Mm-hmm. So I'm going for an approach that is going to be ON time.
ON time? Oh, geez, I can't even think of an ON time solution.
Lucky me.
How would I do this? Okay. Wait a second. Why is, in this first example, why is there only 4 good pairs? Shouldn't there be 5? Because 1 is smaller than 2, is smaller than 3, 2 is smaller than 3, 1 is smaller than 3, 1 is smaller than 3.
The numbers need to be equivalent and the indexes need to be smaller.
Oh, a pair is called good if the numbers are equivalent and okay, that makes a lot more sense. I was just thinking about all pairs that were smaller than each other. See, I don't read problems correctly. This is my #1 problem in coding interviews, is I actually don't even just read the problem. I feel like you're right there, and I have to think about this a little bit more. Oh shoot, you actually have to return them. I think I can still do that.
I don't think you return them. I think you just return the count.
Oh, you do? Okay. Thank goodness. Is this Python 3 or 2? Does that have a problem? Oh, you beat me. Solution. Shoot.
I don't think it was that performant. Like I thought originally it was going to be ON, but I got to ON log n time.
What, you sorted it? You sorted the array? I want to look at your solution. I'm going to look at your solution. All right, what did you do? Okay, so you made a new map. I did that too. For each of the things, exists equals count. So you get the index. Okay. If it does not exist, you add it in there. You put a new set in there.
Mm-hmm. Okay. So I want a list of the indexes that are matching that value.
That's exactly what I did. Okay. What did I do wrong? I must have done it wrong here. So key value pair in the entries, you sorted.
Yeah, because if you don't sort it, then there's an opportunity that a higher index is closer to the start of the array, and then you won't match it to a lower index when you were supposed to.
Yeah, because if what I figured is if you're adding them into the list as you go and you add them in the correct order, then they should be further along in the list. Like they should be ahead of it. So I don't know why this didn't work.
Oh, I understand what's happening right here. So you're doing the length -1, right? And for that first array 0, 3, 4, that's giving you 2. But inside that, that's actually 3, right? Because 0 to 3, 0 to 4, and 3 to 4.
Oh, right. Okay, so what is the correct way to find the number of pairs then? It's probably some exponent because each entry is less than the entries ahead of it.
It's almost like I feel like there's a math equation for it.
There's definitely a math equation. I can't think of what it is.
Yeah, but I think you can do it the brute force way. It's pretty trivial.
So if there was like 4 entries, 1, 2, 3, 4, it would be 3 plus 2 plus 1 plus 0. So essentially it would be the length. What is that? Okay, length plus length minus 1 over 2. Let me try that. But it's also 1 below it. Okay. This is going to be stupid, but we'll see if it works. I'm just kind of curious now.
No, this is good. I mean, the point of this extension isn't fully about just competing and getting the right answer. Like these kind of situations are exactly what is going to help you improve and become better at these kind of interviews. So just because I got one, Jason's going to get the next one, and I'm going to be in the same boat, and we'll both learn from each other. And in the end, it'll be much better. And if this goes through well, then his will be for sure a lot more performant than mine.
Okay, let's submit that and see if it works. There we go.
You would have won for sure based on performance. That is performance as well as memory. Improvement. Unfortunately, I'm going to win just because of writing time, but you would win in the future, potentially, if you had maybe been a bit quicker. See how the math adds up. In the future.
Also, I think you told me what was wrong with my code there. And so I sometimes get way ahead of myself where I'm like, I just want to be done with the problem. And so I'm like, okay, now I've got the pairs, I'm done. But I didn't think about it like, oh, okay, each pair, it's more than just n pairs. It's actually the summation. So for anyone that's curious, this here, the reason I did this is because each pair is like, if you take the first entry it is like every entry above it, and then the next entry is every entry above it, and so on and so forth. And so what you end up having, if you have 4 in the list, you have 3 plus 2 plus 1 plus 0. The summation formula, if you have like 1 plus 2 plus 3 plus 4 plus 5 all the way up to n, you just do n times n minus 1 over 2, and that gives you the summation. So in a nice closed form. So
a lot more elegant solution than mine, for sure.
Well, that was actually like a lot of fun. Like I really enjoyed that.
Yeah, it was good. It was enjoyable.
Okay. Will we do another one? Okay, so we found a new problem to do. So again, like right now, we only have a feature where you create a room for each problem. In the future, it's going to be like you can keep the room going with new problems, but right now you just have to create a new room every time you get a new problem. And so we're going to do this one: split a string in balanced strings. I'm going to go ahead and send that to Javin.
So a few things to note while you're doing this, and this will come in the new feature, is you want to try your best to be under 30 minutes. When you're doing interviews, going above 30 minutes is usually pretty detrimental to the interview. So we are in turn going to negatively impact your score if you go above 30 minutes. So really 10 to 20 minutes or 0 to 10 minutes is very optimal. 10 to 20 minutes is average. 20 to 30 and onwards is a bit slow. So try, if you're maybe getting to that 20-minute or 30-minute interval, cut yourself short and look at someone else's problem. It'll help you in the long run for interviews, as well as just being more higher velocity while writing these questions.
Yeah. And of course, it does have some, like, depends a little bit on the problem itself. But what you'll find is that you'll either get a 30-minute long interview, in which case you're going to have to solve the problem in 20 minutes. Like you have 20 minutes because the rest of the time is talking. And if you get an hour long, then you might get 2 20-minute problems, actually. You might not get a 30 or 40-minute problem. You might get 2 20-minute problems. So definitely a really good thing to point out there, Javin.
Yeah, and final note is I've been impacted by this previously, but if you're doing a technical interview, the main concept of it is the technical part. Don't go crazy talking about yourself. That's usually done in other parts. Leave yourself the time to actually do the problem.
Definitely. Okay, so I'm going to read the problem before I ready up this time. So balanced strings are those who have equal quantity of L and R characters. Given a balanced string S, split it to the maximum amount of balanced strings. Return the maximum amount of splitted balanced strings. Example 1, RL, RR, LL, RL, RL. So there's 4 there. You've got the first one, the very first 2 characters, and then you've got RR, LL, and then you've got RL, and then you've got RL one more time. All right, now I'm going to ready up, get this thing out of my way again. You know what? Actually, I need to take a swig of water. This is like intense. I'm really glad we made this extension, man, because I'm actually enjoying it a lot.
It definitely makes the experience a lot more enjoyable, no doubt.
Okay, right. 3, 2, 1, start.
Here's coming.
I'm trying to wonder in Python, how do I check if an array is empty? Because I'm worried it would just equate the 2. I guess you could say not. Okay, never mind. I worried it would try to equate the objects on like the address level. Let's see what happens here. Oh, I didn't even return it. Okay, I got a accepted runtime. Ah, shoot.
So I'm doing a stack approach. Essentially, I am going to be counting the characters, and then once they are equivalent, I will iterate a total count and reset the original character counts.
That is basically what I'm doing. I got tripped up by example 2, just so you know, so you might want to take a look at that. Maybe you're much smarter than me.
I don't know about that.
Oh my God, you submitted already?
I think yours is more performant though.
Here, just gonna say.
Are you making sure to reset your counts?
Yep. No. There, I submitted mine.
Wow, how are yours always so much more performant than mine?
I'm really mad that we don't have this feature out right now where it would be working.
Like
I would be
win both of them, to be quite honest. But
so let me.
Like, is there a difference in language performance? Is that significant?
There could be. There actually really could be. Like, you can try taking my solution and running it and like rewriting it in JavaScript and see what happens.
I wonder. Yeah, I wonder.
So if S, I at R, right count plus plus, left count plus plus, if they equal the same thing, total count plus plus, and then reset them. Okay. That probably makes a lot more sense. Wait, actually, I'm kind of surprised that works.
Why? It's kind of like a greedy approach, right? I'm just, because I know if I can find something the first time I find it, it's going to be the minimal, which leads to the highest quantity.
That makes a lot of sense. What I did, my approach was, so it was wrong. Like the first time I did it, it was wrong because I thought that it had to start with an R and then end with an L, but it could be LR. And so here's what I did. I basically decided this leading char, set it if it's like the beginning. If the first char is the leading char, then add it to the stack. If not, pop it from the stack. If the stack is empty, then count +1 and reset the leading char.
Yeah, I think yours would be more memory performant than mine.
You think so? I actually think mine would be less memory performant because I'm storing all of like the list.
Yeah, actually you're right.
2 numbers.
I'm just storing a single integer.
Yeah, you know what? There's definitely like some foul play with languages here because yours is like your memory usage is so much higher than mine.
That's something that maybe we should account for in our next iteration of our extension. If anyone has any insight or recommendations, we are more than open to getting them. You can reach us at contact@leetsparty.com.
That's a good point. We definitely should take that into consideration. Maybe for like the beta version of this feature, we just like default to writing time if you have different languages. But we'll talk about that after this episode is over. Well, anyway, I got beat twice, but I had a lot of fun, and I actually felt like I actually learned something here today.
I don't know if you got beat twice. I beat you in writing time, but you 100%, there's not even a question about it. And the first one was way more performant, way more memory performant. So I feel like I just, I beat you in the writing time. That was basically the only category that I beat you. And I think the second problem, I think we're pretty equivalent.
Yeah, you know what I think is like really comes out to me is like what I do wrong in interviews is I always don't read the problem or read the test cases because I think I could have beat you here if I had realized that R is not always the leading character. Like if I had just known that, then I would have done this in the beginning, but I didn't. And so therefore I had to run it and feel, oh, okay, now I'm wrong. And then go back to the drawing board. And then by the time I had done that, you'd won.
Well, I heard you say, "Oh darn!" Like you submitted it and it didn't work, and I was like, "Oh shit!" I'm still writing. So if that submission had worked, uh, based on what you said, then you would have 100% won in every single category.
Well, I had so much fun. Thank you, Javin, for first off helping build this like really cool platform, and second off for beating me live on camera today. Embarrass me.
Thanks for having me. It takes, I like to say this, it takes two to tango. I did not build this extension by myself. We have an Asana board that we have a lot of the tasks, and we have been actively working together for the last month. And I think I may have just won based on an edge case, not necessarily that I actually won, but I'll take it.
And today I feel like we did 2 ranked easy problems on LeetCode. So the next time we do this, we're going to have to up our game a little bit.
Yeah.
But for today, we haven't done this in over a year.
Yeah, no, I don't think either of us have much experience recently. So.
Okay, well, that's it for the show today. Like Javin said, you guys can reach out to us at that contact email, or you can just go to leetparty.com and you can learn more. You can find out how to contact us, and possibly get involved in helping build some of these features. So that would be really cool. Again, you can find me on LinkedIn, Jason Goodison. Javin, you can find on LinkedIn too if you want to reach out to Javin and talk with him. He's a software engineer at Uber, and I'm at Microsoft. So. Great. Thanks so much for joining us today, guys. We'll see you next week.